Today was day 3 and the final day of the AI Engineer World's Fair in San Francisco. I'm going to cover the highlights from the keynotes and then the 2 tracks I mostly attended on reinforcement learning and on robotics. The day started off with a keynote from Google, from Logan Kilpatrick, and he announced the launch of Gemini 2.5. This is kind of the third or maybe fourth relaunch of the 2.5 Pro model, and it brings it up to match on most benchmarks, somewhere around 3 from OpenAI and somewhere around Claude 4. This, he says, is the last relaunch of the Gemini Pro 2.5 model, suggesting the next time there is a launch of the Pro, it would be number 3. He also gave a few tips on what might be coming from Google over the next few months. It appears there will be some Gemini embeddings that will be released. This makes sense to me. Google probably has an excellent store of data, and so it just makes sense to release these kinds of models, the embedding models, and indeed open source models, because they have access and a competitive advantage on the data front. There's a suggestion that Gemini Code might be released. Of course, OpenAI have Codex, Anthropic have got their Claude Code, so it would make sense for Google to have its own in order to push the use of its Gemini models. Computer use API upcoming as well, and also an emphasis on evals tooling. Interestingly, there was a survey done later in the day, and it shows that one of the biggest problems, in fact, the biggest problem listed by developers in the survey, is running evals. The second biggest problem is the reliability of LLMs. Now, moving on to some analysis from George Cameron, one of the founders of artificial analysis. You can see here just in how much trouble the US models are when it comes to open weights compared to the Chinese. Out of the top 10 open weights models today, there are just half of them that are US, or not necessarily US, but well, are they US? I guess they are all US, whereas the others are Chinese based, and indeed the top 2, DeepSeek, the recently re-released DeepSeek R1 and Qwen, model from Qwen here, are top of the open weights leaderboard. Interestingly, Nvidia has got 2 of the top 5 from the Western models, Microsoft and Llama, not even featuring here at the moment on the open weights models in the reasoning category. When you move then to non-reasoning category, Llama does make an appearance here with the Maverick and the Instruct model. Of course, Llama has not yet released a reasoning type model. Perhaps they will as a later release of the 4 series that we shall see. Now, there was an interesting developer survey. I've mentioned it briefly there already, but done by Barry Yaron of Amplify Partners, a VC firm, I believe. And this survey of developers asked, what techniques are you using to customize your AI systems? And on the x-axis here, it goes up as far as 80%, by the way. So it seems nearly 80% of developers are using few-shot learning. Seems plausible to me, although still high. RAG, somewhere around 75%, but fine-tuning at 40%. And you'll often hear on YouTube or at these conferences that, fine-tuning is not really used so much because the models are just so strong in general. So I was kind of surprised to see this number here that 40% of developers are using fine-tuning to customize their models. So, maybe it's a good thing I'm making all these videos on LoRa and QLoRa. Another survey question here, what percent of respondents say they're using this modality of models at work? And you have 75, 80% saying text, then about 20% saying image, same for audio and less for video. So you can see there's a long way to go here in adoption still of the image and the voice models and indeed the video models. And there was a slide shown after this, which shows, do you think you will soon adopt this modality? And the largest jump there, I think it was a jump of about 30% in audio and voice. So there's clear signs in the data that there's going to be first a jump up in the audio voice, maybe then a little bit in image, and then last up in the video front. Now, one of the last keynotes I'll highlight is from OpenRouter founder Alex Atala, who actually was a founder of OpenSea, I believe, the NFT trading firm, maybe platform rather. He's maybe still involved, I'm not quite too sure. But OpenRouter is a platform that allows you to use with one API key to make calls to any of the public LLMs like OpenAI, like Gemini, what's the other one I'm missing? Anthropic. And I thought initially, well, this is kind of silly. Why would I want to do this? Especially because they charge, I think, a 5% premium. Why don't I just use Light LLM, which is another wrapper? But Yeah, I mean, even before this conference, I've come to appreciate just the convenience of having one API key with a fixed spending limit, and you can hit all the models. And this is the growth here. There's been 10 to 100% growth month on month for the last 2 years. And they're processing, I think, something like hundreds of trillions of tokens per month. If you assume like $1 per million tokens on average, that would come out to a volume of hundreds of millions of dollars flowing through in terms of compute credits every single month. So a very fast growing platform. And I know this graph is very hard to see, but there's an added benefit to using OpenRouter I didn't appreciate, which is that if you query, let's say, the Anthropic models, there are actually different endpoints you could use. You could use Anthropic's version, you could use Amazon Bedrock's version. And because OpenRouter is able to route to any of those, and I should say OpenRouter because I'm Irish, but because OpenRouter can use any of these, it is able to provide a better uptime guarantee than any of these endpoints individually. So it's kind of at this weird advantage that it can provide higher uptime guarantees than Anthropic is capable of itself. Now, moving on to reinforcement learning, quite a few interesting talks here, and also the ARC Prize, which I'll mention towards the end of this. My view is reinforcement learning is still, people don't have a handle on exactly how the big labs are doing it. And there are a lot of mixed messages that are coming out about what is effective, what does work in terms of improving performance or not. And one of the interesting aspects of improving reasoning models is that probably the simplest way to improve reasoning through tuning is simply taking high quality reasoning traces from the best private models and not even doing reinforcement learning, just doing straight supervised fine tuning. So running these reinforcement loops to really improve the performance of a model using these, I think you probably need to be at the frontier level or close. If you do it at a lower level, there may be cases where it improves your performance a bit, but there are so many variables and there seems to be a lot of contradictions that come out. I'll just give you one example here. Sorry, I've been showing this slide for a few seconds now without saying anything. This is a slide from Ryan Martin of Bespoke Labs, who's involved in leading a paper called OpenThoughts. The idea is to create a data set of thoughts that can be used to fine-tune models to reason better. And there are some pretty unintuitive things that were found here. A set of thoughts were generated by sampling questions, first of all, from science, maths, and other knowledge data sets, and then getting open source models like DeepSeek, like Qwen, to generate high quality answers, and using these questions and answers then to train a 7 billion parameter model. Now, one thing pretty unintuitive here, answer filtering and verification didn't actually improve performance. So if you took all of those traces and used some programmatic verification of the answers, either LLM as a judge or just numerical verification, and you filter out the wrong ones, that actually didn't improve the results, which is very counterintuitive. Now, granted, I looked a little bit at the paper and 80% of the initial data set were already correct. So filtering out that 20% is maybe not a huge factor. Furthermore, when you are training a very weak model, if you are providing some wrong answers, just the fact that those wrong answers are structured well because they're from a much stronger model probably will help to improve the weaker model. So the message I'm seeing here is that when you train weak models to try and pull them up to a high model level, that's actually a different task than trying to incrementally improve the model that is the very best at the top. I'll point you maybe as well to my SFT versus GRPO video, which talks about just doing straight fine tuning versus reinforcement learning, because I think some of the messages, even though that video is from earlier this year, are actually holding up fairly well. Now, Nathan Lambert, who works with Alan AI and has been involved in training models like Tulu. Tulu is actually open source, not just Llama open source where the weights are open, but open source in the sense that the data sets are open as well. This is the approach Alan AI takes. It's a more purist open source approach. And Nathan Lambert gave a talk also in the reinforcement learning track. Here's a slide where he highlights how overthinking is still a major problem, not just in open source models, but private models. A nice question you can ask is, what's 2 plus 3? And it turns out that, these two of these are open source models here, and they require almost 1,000 tokens to answer that question. But even O1 Preview and O1 Mini take 200 tokens, whereas some of these non-thinking models will just straight up answer it within 5, 7, or 12 tokens. So controlling the amount of reasoning is not something that is really controlled entirely. Actually, that was mentioned by, I think it was maybe one of the founders of DeepMind, one in the morning keynotes, that managing this reasoning and getting the models to use the appropriate amount of reasoning is still kind of a major question. Interestingly, in building these open source data sets, like this one from Bespoke Labs, the length of the response is used as an indicator of response quality. But I mean, that's kind of a contradiction if at the same time, the length is kind of a bad indicator because the models tend to overthink. So this just drives home some of the open questions here around reinforcement learning. Now, one point Nathan made that I appreciate a lot, not something I've thought too much about. He's of the view that language models are not particularly good at planning today. And when they do plan, as in Codex or in Claude Code, it's because they're being prompted very carefully in order to do the planning phase. If you ask a model, even a reasoning one, to take on a difficult question, it won't necessarily do a good plan. It will just kind of crack into the question with reasoning. And so this little piece of pseudo kind of response here shows a little planning section of the response, then a thinking section, and then an answer. And this is Nathan's hypothesis that maybe there'll need to be a period where we train models to do some planning, then thinking, and then answering. Now, to round things up, ARC gave a talk today. One of the founders of the ARC Prize, Greg Kamrat, Mike Knoop, was there as well. I was able to have a nice chat with Greg and with Mike and also with Brian of ARC Prize. And here is a little video giving you a preview of ARC Prize 3, which is not out yet. It will be there next year. And it's actually based on these little computer games. So not only will you have to get these grids right, but you would have to solve a computer game in ARC 3. And I know this is kind of bad quality, but, think of some kind of Atari games here where you have patterns and games that need to be solved. There'll be a few examples, and you will have to go into the game, figure out what the rules are and solve it, much like, games that are fun for humans. But it's not like the rules would be explicitly explained. You literally have to explore the game. And when I say you, I mean an AI. Now, one of the questions I asked, I think it was Greg, why doesn't something like Google's AlphaZero that solved chess solve these kinds of problems easily? And part of the answer is that, well, even AlphaZero had access to a lot of data, a lot of training data. Yes, the rules weren't laid out explicitly for AlphaZero, but there was a lot of data. And this is very different in ARC. You're just given very few exploration examples. You can just kind of play the game live, but you're not given a vast range of training data. So that makes it a very different challenge. Now, I'll move on to the last section here on robotics. And this started off for me with the talk from Waymo. Here, sorry for the kind of dull, bright screen, but Waymo now live in quite a few US cities. Here in San Francisco, I actually took it for the first time this week, thanks to my friend who booked me one, because you need to have a phone in the region to be able to, you need to set your phone region to here to be able to use it. San Diego, I think Vegas, Dallas, New Orleans, Nashville, Boston, and also Tokyo, Japan. So Waymo really taking over. I believe that the number of rides, and I think it's number of rides of Waymo in San Francisco has now surpassed Lyft on a monthly basis. So very large number of rides. And interestingly, this prompted me to look up with ChatGPT some of the features of Waymo. And there are a few things that are interesting. One is that apparently, and I would need to double check this, there are 4 Nvidia H100 GPUs in each Waymo. Correct me in the comments if that's wrong, but obviously that is significantly expensive. You're talking, tens of thousands worth of just GPUs within the car for that. Also, Waymo relies, I believe, on high definition maps. So it can map, basically every street is mapped within a centimeter resolution. And this allows, in combination with Waymo's LiDAR, so when it uses its LiDAR to detect everything around it, it's able to kind of correspond that to the map, the pre-map. And that gives it very good grounding in where it is. So it's not just relying on vision, like, say, the Tesla model. That is kind of the big difference between Waymo, where they have pre-mapping plus LiDAR, and you have Tesla that's just vision-based, but no mapping. So one of the big questions, of course, with Waymo or any type of autonomous driving is, well, how do you handle with the 0.000, like 5 or 6 zeros, 1% of cases where something weird happens? And what was the example he gave? There was an example where the car was going by a red light, but that made sense because there was a man on the side of the road, like a construction worker, waving them through. So this is a weird situation where you actually should break the red light because you're being instructed to, maybe by a police officer or some kind of construction worker. So how do you handle these cases? And the answer in today's video was, today's presentation was, you use Gemini 2.5 Pro because it can describe in a very, in a natural language way what's happening within images. This is maybe the image of being passed through by a construction worker with a red light. You're not going to be able to see it here, but it's able to very accurately describe what's happening. Oh no, this is an example of a girl falling off a scooter suddenly on the road. So they have literally fine-tuned a model, which I think is based on Gemini 2.5 Pro, and the fine-tuned model is called Emma. They fine-tuned it on tons of trajectories taken from cars, and this is able to generalize extremely well. And I don't know why I didn't think of this myself. Now, the question is, how do you get Gemini 2.5 Pro into a car? Well, I guess if you have 4 H100s, maybe that's not so hard. Gemini Pro, I assume, is very large, like maybe, I don't know, definitely hundreds of billions of parameters. So you're talking about even finding quantization techniques or potentially distilling the model so that you can fit it on those 4 H100s, if indeed that's how much compute they need within a Waymo. Now, the other part of the robotics track was to do with robotics, namely humanoids. And the motivation you'll typically hear at these conferences is that there are a large number of vacancies. If you look at the sectors, say leisure, healthcare, construction, professional services, transportation, manufacturing, all 5 out of 6 of those that for professional services are jobs that require physical labor. And these are jobs where there are big vacancies, and the vacancies have apparently been growing since 2010. I would need to look through that in detail. I'm sure it depends by country. And this, therefore, is one of the motivations. And I'm realizing here this is not the right name for this presentation because it was given. I'm not quite sure who this talk was given by. It might have been the talk by Nvidia on Gr00t. So Gr00t is a model. In the same way Lambert is a foundation language model, Gr00t is kind of a foundation model for both language, vision, and actions. And so you can actually kind of decode actions being the positions the motors should be in the future based on the language instruction you give, like pick up the apple or move the arm or something like this. And hopefully I'll be covering the Gr00t model a bit later on this channel. So robotics was the theme of the day for one of the tracks. And just the last thing I want to highlight out of that is this K-bot. There are probably some of the best known humanoid robots are Tesla's Optimus, which might retail at maybe 40, 50, 60,000. There's also Figure, maybe similar type of robot. Apparently the Tesla robot is particularly strong. It's suited for industrial applications. Well, this is an open source robot, K-bot, that comes from K-Scale Labs. It's initially being priced at about 9,000. It's similar maybe in functionality it could do, but it's not got motors that are quite as strong as Optimus. Now, maybe that's being a bit too generous to K-Scale. That's what was said at the talk here. But it's great to see there are fully open source designs. And it's great to see this price tag here, which is not even the full at scale pricing the speaker was saying. So this would be expected potentially to fall a little bit more as well. But there are also setups now that are making these a lot easier to train. You don't need physical robot data to train them. You can train them in simulation environments, either just by creating simulation paths of the robot, or sometimes by using things like an Apple Vision Pro and then moving your hands kind of in this simulated way to move the equivalent kind of joints of the robot. So simulation is making it a lot easier to gather data. Of course, one of the key problems in robotics then is now, if you have this simulation data, how can you make it transfer as robustly as possible to the practical robots? But robots, although only one of the tracks out of probably well over 20 tracks throughout the last 3 days, I expect this is going to change. And maybe I would say even in 1 year, there'd probably be 2-3 tracks of robotics and could go on significantly from there. I can see how the state of the models, these language, vision, action models, I can see how they resemble a little bit the early multimodal models like say Edifix 1 or even some of the early Llama vision models like Llama 2 with vision. So yeah, maybe like Lava. Lava is the model I was trying to think of. There's just a lot of room, a lot of low-hanging fruit for improving the performance of transformers as applied to robotics. So folks, that is it for this presentation. These 3 days of the World's Fair. You can check out, I've made a playlist. I'll put it in the description if you want to see all 3 days of recaps. There's also the Trellis talk. Trellis had 2 online talks at the AI World's Fair, one on voice fine-tuning, text-to-speech, that's the Sesame model, and the other, which I think is quite an instructive video, is fine-tuning a language model for multi-turn agent actions using MCP. And the MCP is actually a browser MCP where you train it to follow a certain navigation path. So that's it from this AI World's Fair. Let me know of any comments below. Cheers, folks.